Welcome back to exercise 8.3. In the previous class of this exercise, we have dealt with questions which involved simple multiplication of matrices. In this class, we are going to put a bit more into the multiplications, though everything is really easy and simple. Okay, in this question, we have to show this is a solution to the given matrix equation. As you see, all are in caps, so these are matrices x square minus 2x minus 3n. Now this looks like a quadratic equation, right? So when we have a solution, what does it mean? It means in place of x, if we put this value, the left hand side should be equal to the right hand side. So solution is given and the equation is given. I means identity matrix. Okay, identity matrix, if you remember, the diagonal elements are 1. Now order of the matrix I is also given. This is the given equation. Okay, and this is the solution. So that means in place of x we are going to write the solution. The value of x is 1 2 2 1. Now when you put this into the equation, the left hand side should be equal to the right hand side. Okay, in the left hand side we have x square, so it's better to calculate x square separately. So you know how to multiply the two matrices. So after multiplying we get x square equals to 5445. Okay, now we have x square minus 2x minus 3i, and the order of the matrix I is 2. Okay, so writing all the matrices, this is x square minus 2 times x minus 3i. I is identity matrix with the diagonal elements 1 and the rest of the elements as 0. So we get the first element as 5 minus 2 into 1 minus 2 and minus 3 into 1 minus 3. So 5 minus 2 minus 3, that's 0. Okay. Again the second element 4 minus 2 into 2 minus 4, and this is minus 3 into 0 0. So 4 minus 4 minus 0, this is also 0. So the third element is 4 minus 2 into 2 minus 4 and minus 3 into 0 0. So we get 4 minus 4 minus 0. And the last element 5 minus 2 into 1 minus 2 minus 3 into 1 minus 3. So we get 5 minus 2 minus 3. So each of the elements we can see it's a 0. So that's equal to O given in the matrix. So that means our left hand side x square minus 2x minus 3i is equal to the matrix O, and hence 1 2 2 1 is the solution, which is proved. In this question we have a matrix A equals to given, and we have to find the values of x and y. Remember, these are not caps, so these are not matrices, these are a particular number. So I have to find the values of the variables x and y, and this equation is also given, a square plus equals to xa plus yi. Again I is identity matrix. Okay, now as we see a square, we need to find a square. Okay, so a is given and a square is a into a, so we can easily find a square by multiplying these two matrices. You know the process of multiplication. So we get 7 12 4 7 after multiplication. Now substituting the values we have got in place of the equation, we got this matrix x into a plus y into I. Now this is important, how you find the identity of the order of the identity matrix. Now as you see, the order of the matrix on the left hand side is 2 by 2, and the order of A is also 2 by 2. So you can add two matrices only if their orders are same. So the order of the identity matrix should also be 2 by 2. Now if we want to equate the left hand side with the right hand side, the right hand side whole matrix should be represented with the help of a single matrix. Now if we add, this is x being multiplied each of the elements, so this is 2x, 3x, 1x and 2x. So 2x plus y, this is the first element of the final matrix, and 3x plus y into 0 is 0, so 3x plus 0. Again x plus y into 0 is 0, x plus 0, and we have 2x plus y into 1, y, so 2x plus y. Now we have two matrices which are exactly equal, so that we can compare the elements of both the matrices. Now as we compare the elements, we can check that x plus 0 is 4. So if we compare the second element also, 12 equals to 3x plus 0, so 3x equals to 12 by 3, that's 4. So we'll get the same value whether we compare this third element or we compare the second element, we are going to get the same value. Okay, so comparing the second or the third element, whichever you want, comparing the first or the fourth element, whichever you want, again on both sides we get 2x plus y equals to 7, and hence y equals to minus 1. So x is 4 and y is minus 1. Here in this question we have let M into a matrix given. So M is also a matrix, it's in caps, and equals to another matrix 1, 2. Okay, where M is a matrix. We have to find the order of the matrix and also the matrix M. If you remember how to find the order of a matrix, now here the order of this matrix is 2 by 2 and the order of the product is 1 by 2. So order of the first matrix we need to find out. So this is, we know two matrices are compatible for multiplication only when the column of the first matrix equals to the row of the second matrix. So the column should be 2 here, so number of columns of M should be number of rows of the second matrix, that's 2, and number of rows for matrix M should match with the number of rows of the product. Okay, so this would be 1. So the order of M is 1 by 2. Now when we know the order of the matrix, only one row and 2 columns, so let the elements be x and y. So let M be this matrix. Okay, now when we multiply M into the given matrix, we get 1, 2. So multiplication is simple again, x into 1 plus y into 0, that's x plus 0, and x into 1 plus y into 2, that's x plus 2, 1. So now we can compare the two equal matrices. So comparing the first element we get x equals to 1, and comparing the second element we get y equals to half. So what is the matrix M? So M is 1 and half. This is the matrix M. In this type of questions, they are not asking you to find the order of the unknown matrix. So find matrix C. You can find the matrix only when you know the order of the matrix. The other two matrices are given. Now as we have discussed how to find the order of a given matrix. So A is 2 by 2 here and B is 2 by 1. So obviously the number of columns of the first matrix should match with the number of rows of the second matrix. So number of rows of C should be equal to the number of columns of A. So that's 2. And number of columns of C, the columns of C should match with the columns of the B. So columns of C should match with the columns of the product. The column of B is 1 and hence the order of C is 2 by 1. Now when we have the order 2 by 1, that means we have 2 rows and 1 column. So let the matrix be in this format where we have X and Y. Now we need to find AC equals to B. So let us first multiply AC. So when we multiply we get 2x minus y and minus 4x plus 5y. So only 1 column and 2 rows. Now since AC equals to B, so we can equate the corresponding elements. We have 2 equations. Comparing the elements we'll get 2 equations. Now these 2 equations can be solved using the methods we know in simultaneous linear equations in 2 variables. So we have used here elimination method. So to eliminate the x part, we have multiplied the coefficient of the first equation with 2, so that we get 4x. We get 2y minus 2y plus 5y, that's 3y equals to minus 4. And y equals to minus 4 by 3. Substituting the value of y in one of the equations, so from 1 we get x equals to minus 36. So the matrix C is minus 13 by 6, x is minus 13 by 6, and minus 4 by 3. Okay. In this question they are asking you to find matrix A. Now if you remember the previous question, we had to find the second matrix. Now here we are going to find the first matrix. Okay. The product is always easy, we just multiply to get the product, but when we need to find one of the matrices in the multiplication part, we need to find the order of that matrix first. Okay, so B is given and C is given. Order of B is 2 by 2 and C is also 2 by 2. So generally when you have a square matrix, so all the matrices are of the same order. The number of rows of A should be equal to the number of rows of the product C, so that's 2. And number of columns of A should match with the number of rows of B only when they can be multiplied. So the order of A is 2 by 2. Since the order of A is 2 by 2, that means we have 4 elements. So let the matrix A be with 4 elements A, B, C, D, and the order is 2 by 2. So if we want to find the product of the 2 matrices A, B, we just write A first and the matrix B and then multiply as usual. We get 4 elements in the product. We know AB equals to C. So this is our AB and this is C. These are equal matrices, so we can compare the corresponding elements. So we can see 2A minus B and minus 4A plus 5B. So there are 2 equations. If we compare the corresponding elements, we get minus 4A plus 5B equals to 17. 2A minus B equals to minus 1, comparing the second element. Comparing the third element, we get minus 4C plus 5D equals to 47. And comparing the last element, we get 2C minus D equals to minus 13. Numbering these equations as 1, 2, 3 and 4. Solving the first 2 equations using elimination method by multiplying the second equation with 2. We get B equals to 5 and then A equals to 2. Similarly, solving the third and fourth equation using elimination method, we get D equals to 7 and C equals to minus 3. So writing all the elements for the matrix A, we get 2, 5, minus 3 and 7. That's the matrix A. That was all from matrices of class 10. In this chapter we have learned what is a matrix, the types of matrices, the order of a matrix, how to add or subtract or multiply a number with the matrix or divide a matrix by a particular number, and how to multiply two matrices having different orders. Hope you have understood all the topic. You can always go back and check the videos if you need help. Thank you.